In this video, we'll do a quick review of this electronics model inside of Simcenter Flotherm XT. Here we are in Flotherm XT. In this project, we have this electronics device, and here we already have the full project defined. We have the boundary conditions, the materials, the power already all assigned. So here I just wanted to show you what the complete project in Flotherm XT looks like. And then in the following videos, we will be creating this project from scratch in Simcenter FLOEFD. Okay, so we'll be replicating this same kind of project in Simcenter FLOEFD. Now in Flotherm XT, in order to start the project, we would go through the wizard where we specify the name, we specify the units we want to use, the types of physics, such as internal, external flow, direction of gravity, steady state or transient analysis, the default material and fluid selections, and so on. And this process is very similar in Simcenter FLOEFD. Here in this project, we have two PCBs, printed circuit boards, and these were imported through Flotherm XT's EDA bridge. Now, if you're not familiar with EDA bridge, that is a bridge that allows you to import everything that you need for a thermal simulation from an EDA tools export. There you can assign different powers for the components. You can define the fidelity of the board itself, so it can be just a simple block with an average material property, or a layer board, or a smart PCB, or on the most detailed side, a fully explicit board with all the traces and vias represented in CAD geometry. And you can import this all into Flotherm XT. So there's other capabilities within the EDA bridge window, but that's for another presentation. And this whole process is also very similar for FLOEFD. Here in Flotherm XT, we also imported two gap pads, and that was done through Flotherm XT's library. Now in FLOEFD, it's going to be a different type of process to do that, so we'll go over that later on. One thing I want to mention is the way to handle overlapping geometry is different between Flotherm XT and FLOEFD. In this example, we have the gap pad and the enclosure overlapping in this area. Flotherm XT will decide which object will take precedence in that overlapping space by utilizing the tree hierarchy. Flotherm XT solves from top to bottom. So in this case, we first see the gap pad in that area, then the solver solves from top to bottom in the tree, and it sees the enclosure is sharing the same area. So in this case, because the enclosure is below the gap pad, the enclosure material will take precedence for that overlapping space. In FLOEFD, the way you tell the software which material to use in overlapping geometry, it is handled a little bit differently. In Flotherm XT, you just move the components up and down in the tree hierarchy, but in FLOEFD, you have a separate window called Materials Priority, where you specify which materials should take precedence based on the priority list that you can modify. Now, this will be more efficient for complex models that have a lot of objects and material assigned. It will be a lot more efficient in FLOEFD's method of handling overlapping geometry. In Flotherm XT, we have this Components tab where you have the properties and you can assign what material it has and assign a local mesh. This all can be done in FLOEFD as well, but it is handled a little bit differently, so we'll go over that in detail later on. Alright, and in Flotherm XT, in this project, we have the materials, some of which came from EDA Bridge, some came from the library. The thermal attributes, these came from EDA Bridge, and at this point, it would be ready to solve for thermal and fluid simulation. In the next videos, we'll show how to set up the same kind of project in Simcenter FLOEFD.